All right, so in this function, we are going to be solving radical functions. So we'll be using square root property to be able to get what x equals, and then we're going to have to check our answers. We're also going to go through a couple applied problems with solving with square roots. Okay, so our first warm-up question, I would look at your book and attempt to do your warm-up question. So try to solve for x. Okay, so I would pause the video, try to get x by itself, try to manipulate the problems to get x by itself. Okay, so this first one, if I'm trying to get rid of that square root, I'm going to square both sides. So I'm going to get x is equal to 2 squared is going to get me to 4. Okay. The next one here, the opposite of cube rooting is cubing. So I can cube both sides, so that's going to cancel. If I type in -2 cubed, so if you type it in your calculator, you do -2 to the third. We are cubing that entire side. So notice that I put it in parentheses, which is a little bit different. Okay, I am cubing that entire side. So I'm going to get -8 because it's like saying -2 times -2 times -2. And our last one, we're going to square both sides. Okay, so -2 squared in parentheses. So -2 times -2 is 4, which actually this one is going to end up giving us no solution, which we're going to talk about why that one is no solution in the upcoming problems here. Okay, so we're going to use properties of equality to solve radical functions. So just when I do one thing to one side, I do it to the other side, identifying extraneous solutions. So that last one was actually an extraneous solution when we are solving. Okay, so strategies for solving equations using the properties of equality to isolate the term. So when you add something to one side to get rid of it, containing the unknown are applicable in solving radical equations. That's how we're going to get through square root property. It says let's compare the algebraic solution of a two-step quadratic equation. So this one we're starting with 2x squared minus 5 is equal to 13, and this one is starting with 2 square root of x minus 5 is equal to 13. So I want you to try to answer the next two questions. So you're going to look at the process of how they solve for x and say, what are the similarities in the first two steps of each of them? Okay, then after you figure out what do you notice is the same, you're going to describe the differences in the remaining steps. So what did they do in the remaining steps after the first two? That was different. So go ahead and pause the video and try to think about what you think they did. Okay, so describing the similarities. So going from the first step down, they both added 5. They both added 5 to both sides to move it over to that other side. Okay, and then it looks like they both divided by 2 to go from the next step to the next step. So they use the same properties to get rid of the numbers and the coefficients to kind of get x by itself. So they're isolating x the exact same way. Okay, so then the next part, question B here. In the last two steps, what did they do differently? So in this step to this step, what did they do differently? So it looks like the one had to square root its answer. Okay, and then this one, opposite of square rooting, is squaring, so they had to square. So remember, when we solve and square root something, we have a positive and negative side to it. Okay, when we square something, we don't have to worry about that. So they just got a positive 81, where the other one is a plus or minus 3. A positive 3 and a negative 3. Okay, so their differences is one had to square root to get its answer, the other one had to square. The other one has 2 answers, while the right one only has 1 answer. So there's another difference. How would the strategy shown in the worked example change from cube and cube root equations? So if I change this to a cube and this to a cube root, that's a little 3, sorry, it looks bad. Okay, so how do I get rid of a cube? Well, this I would have to cube root. How do I get rid of a cube root? Well, this I would have to cube. Okay, if it was 4th root, I'd take it to the 4th power. If it was 5th root, I'd take it to the 5th power. Okay, so let's look at different strategies for solving radical equations. You can solve a radical equation with a single variable term under the radicand or radical equation with more than one term under the radicand. Okay, so we are going to have to check our answers because in some instances we're going to get what x equals. So like when we do rational functions, we have our restrictions and our extraneous solutions. Our extraneous solutions, where when I plugged them back in, they gave me an error in my calculator. So there's going to be something similar to this. We have extraneous solutions that when I go back to plug it back into the equation, it doesn't actually equal what it needs to equal. So we need to check to make sure that our answers are okay. So we have 3 square root of x plus 7 is equal to 25. And then we have square root of x plus 1 is equal to 8. So the first question, how does the form of each equation relate to the solution strategy shown? So why does the original affect the process? So when I have my original equation, what do those numbers do that affect my process? Okay, so on the left one, we actually need to do a lot of work to isolate that square root of x. So we're going to have to get rid of the numbers. So you have to get rid of 7 and 3. So remember, you work outside in. So you have to subtract 7, then divide by 3. This other one, we can't subtract 1. That 1 is in the square root. So the very first step we actually have to do for that one is get rid of the square root. Okay. The other stuff, or the left side one, we have to get rid of the numbers to isolate the square root of x. Okay. The right side, we can't subtract 1 because he's underneath. He is attached to the square root, just like parentheses sets. We would get rid of it by squaring first, and then we could subtract that 1. Okay. So it depends on where the numbers are and how you can actually isolate the square root of x. So raising both sides of an equation to a power may introduce an extraneous solution. So it is important to check your answers. Extraneous solutions are solutions that result from the process of solving an equation, but are not valid solutions to the equation, which means when I plug them in, they won't work. Okay. So my first one. Everything's underneath the square root, so to get rid of the square root, I'm going to square both sides. So that's going to cancel this. Okay, 3 squared is the same as 3 times 3, so I get 9. To detach, I would divide by 2. We're going to use the decimal because it's going to be easier to plug in the decimal and check it. So we're going to check it now. So I'm going to take that x out. I'm going to shove that 4.5 in. And we're going to only manipulate the one side here. So 2 times 4.5, or you could just type that in your calculator, is 9. The square root of 9 is 3. We weren't actually solving this time, so I didn't actually put a plus or minus on that 3. Okay, we were just kind of simplifying the square root. So that one checks out. 4.5 is a possible solution. Okay, this next one here, everything's underneath that cube root, so I need to get rid of the cube root first. So I'm going to cube both sides to cancel this. Okay, remember if you need to type 2 cubed in your calculator, do 2 caret 3. Okay, and then put it in parentheses just like I did. So this is going to give you 8. Now I can just solve for x. So I'm going to add 3 to get 11 and divide by 2 to get 5.5. All right, so now we're going to check it. So I've got the cube root of 2 times 5.5 minus 3. So 2 times 5.5 is 11. 11 minus 3 is 8. Okay, and now I'm going to show my graphing calculator up here, and I can show you guys how to type in the cube root if you don't remember it. All right, so I'm going to go to math. I would prefer you guys to use the one with the x. There is an actual cube root button here. Okay, we are going to click this one here. So the first thing I actually have to do is I need to type the 3. Then I'm going to press math. I'm going to go to this one. This one means I can type in any type of root, 4th root, 5th root, 6th root. Okay, so notice it is now cube root of x, and then we are typing in 8. Okay, because it's saying what when I take it to the 3rd power gets me to 8. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. So 2 is equal to 2. So 5.5 is good. And my next one here, I have that 4 I got to get rid of. Okay, because you need to isolate the square root first. So it's like being multiplied, so I'm going to divide it to get rid of it. You cannot enter a square root wall. Okay, so I can't weirdly distribute this 4 in. That square root is like a wall. To get rid of it, you have to square it. Okay, so I got what I did to one side, I did to my other side, so I got 2. So now I'm going to square both sides. So this will cancel. So I got x minus 6 is equal to 2 squared is 4. And now I can add that 6 to get 10. So now let's check it. So 4 square root of 10 minus 6. So 4 square root of 10 minus 6 is 4. Square root of 4 is 2. It is still being multiplied. Do Do not try to add it. Do not put a plus sign where there is not a plus sign. 4 times 2 is 8. Okay, so x equals 10 was good to go. Okay, why don't you guys try the next 3? So pause the video and see if you can do the next 3 on your own. All right, this next one here, I'm going to square both sides. So 2x plus 1 is equal to 5 squared is 25. Then subtract 1. Divide by 2, so I got x is equal to 12. I'm going to check it. 2 times 12 plus 1. Okay, order of operations, PEMDAS, parentheses first. So 2 times 12 is 24. Okay, I don't have exponents, don't have anything to multiply, don't have anything to divide, so I'm going into my add to get 25. Square root of 25 is 5. So he is good. Okay, this one, to isolate that root, I'm going to work outside in, so subtracting 16 first. Then it still multiplies by 2, so I divide by 2 to get rid of it. Okay, so I've got cube root of x is equal to -8, so I'm going to cube both sides to cancel it. So it's like doing, so remember when we converted this, it was to the 1/3. Okay, so exponent over radical, if I was converting it to exponential form. So what you're actually doing is you're timesing it by its reciprocal, 3/1. That's also why it works, okay, because if I do 1/3 times 3/1, that actually becomes 1, which is what I'm trying to solve for, so x equals. Then I'm really doing -8 to the 3rd power. Is -512. Okay, now let's plug it back in. 2 cube root of -512 plus 16 needs to be equal to 0. All right, let's type in my cube root. So -8. So 2 times -8 plus 16. Okay, 2 times -8 is -16. -16 plus 16 is 0. Okay, so notice I did my PEMDAS again. Okay, in my parentheses first, that's why I did 2 times -8 to get my -16 to then add it. All right, so that one was good to go. So he was a fine answer. Okay, this one I'm going to subtract 9. Square root. I'm going to square both sides. So 3x minus 1 is equal to 1. -1 times -1, or use parentheses when you type it in. I'm going to add 1. Divide by 3. Okay. Now I'm going to check it. Square root of 3 times 2/3, or you can use the decimal. Just be careful if you're rounding. All right. Order of operations, parentheses first. 3 times 2/3 in parentheses 2/3 will give me 2. 2 minus 1 is 1. Square root of 1 is 1. 9 plus 1 is 10. This is extraneous. He is not an actual solution that's going to work and give me a response. Okay, so Martinez solved the equation x minus square root of x is equal to 2. Explain his error, give the correct solution in his explanation. So what he decided to do was he subtracted this x over, okay? Then he decided to divide all of them by -1 so that his front guys were positive. So it became a positive square root of x, a positive x, and a -2. So it's like he divided everything by -1 to flip all those signs. Then he was like, well, if I'm trying to get x by itself, I know I can square this, which means I square that whole side. Notice he used parentheses. Okay. He then wrote this out twice and distributed it. That's how he got this. I was like, well, I still got to get it equal to 0 so that I can factor it. So that's when he subtracted this x over to be with his buddy. He factored it and he got 4 and 1. Okay, so what did he do wrong? What's wrong with his answers? Well, he didn't check his answers, right? So we need to go back and we need to actually check to make sure that both of them work. So I'm going to plug, we're going to do 4 first. Notice I'm only plugging in 1 at a time to check it. All right, so I plugged the 4 in for both those x's. I plugged it into the original just in case I mess something up. Square root of 4 is 2. 4 minus 2 is 2. So that one was fine. Now we're going to check 1. So 1 minus the square root of 1 is equal to 2. So the square root of 1 is 1. 1 minus 1 is 0. So this was an extraneous solution. So when you're solving these, you need to be checking your answers to make sure they actually work. Okay, so go ahead and see if you can solve this equation if you want. So pause the video. Okay. I can't subtract the 1 over because it's underneath my square root. So the first thing I'm going to do is I'm going to square it. All right, so it's going to cancel this guy. Notice I have this in parentheses, which means I need to write it out twice. That canceled him, so now he's just an x plus 1. So it's like you can't really move anything until you get rid of that square root. So your end game is like, do I need to move anything or can I get rid of the square root? Because I can't solve anything if there's still a square root there. So that's kind of why I took the first step of squaring. Okay, so if you double rainbow, x times x is x squared minus 1x minus 1x plus 1. Remember, you are multiplying when you do that. So that gives me negative 2x. I got x squared and x in the numbers, so I'm going to end up snowflaking. So I'm going to subtract this 1x over and subtract this 1. So it becomes x squared minus 3x is equal to 0. So you could snowflake this. I would prefer you notice that there is a GCF. So if you take that GCF out, x squared divided by x is x, and this would give me 3. If you snowflaked it, your a times c would be 0. Your b is negative 3, x and x, so it multiplies to 0. Add to negative 3 is negative 3 and 0, which is the same as what I have. Okay, this x is just x plus 0. Remember, whenever we're doing ZPP property, anytime you see an x, you solve it. So I have x is equal to 0 and x is equal to 3. So now we got to go back and check them. So x is equal to 0. 0 minus 1 is negative 1. 0 plus 1 is 1. Square root of 1 is 1. So that one I already know is extraneous. Now we're going to test out 3 here. So put it in for both of those x's. 3 minus 1 is 2. 3 plus 1 is 4. Square root of 4 is 2. So 3 is my only answer that works. All right, so now we're going to work into our apply problem. So the Beaufort scale is a system that measures wind speed and describes conditions at sea and on land. The scale ranges from 0 to 12. A 0 on a Beaufort scale means that the wind speed is less than 1 mile per hour, and the conditions at sea and land are calm. A 12 on the Beaufort scale represents hurricane conditions with wind speeds greater than 74 miles per hour, resulting in greater than 50-foot waves at sea and severe damage to structures and landscapes. So consider the equation that it's representing. V stands for between wind speed and miles per hour of the Beaufort numbers V. So it says solve the equation for V. So we're needing to manipulate this to get V by itself. So if I work outside in, I need to get rid of this 1.8753. So it is being multiplied. So I'm going to divide him to get rid of him. So I have V over 1.8753 is equal to V to the 3 over 2. So that is an exponent. So how do I get rid of that exponent then? How do I get rid of the 3 over 2? So remember, it is kind of like the, if I do exponent over radical, it's the square root of b cubed. How do I get rid of that? Okay. What I'm going to do is I'm going to do it by the power of his reciprocal. So I'm going to take this to the 2/3. 3 over 2 times 2 over 3 gives me 1. So I've got v over 1.8753 all to the 2/3 power or exponent of a radical means it's the cube root of b over 1.8753 squared. Okay? N equals b to the first now, which I don't really need the 1 in there. So then the next question says, determine the Beaufort number when the wind speed is 20 miles per hour. So that 20 miles per hour stands for that B. So I'm just going to take that and plug, this is for B now. I'm answering question B. I just have my equation on here. So I'm going to plug that 20 in for that B, because that B stood for the miles per hour. So I'm going to type this in my calculator. 20 divided by 1.873, all to that. If you don't get prompted for that exponent, you have got to use parentheses around your 2/3. I have the exponent up there, so I don't technically need the parentheses, and I'm going to do it to the 2/3. Okay, so 4.8. So that answers that question B, 4.8. So the next one, we got a new equation where we are doing body surface area. So the equation of body surface area is equal to the square root of W times H divided by 60, where W is the weight in kilograms and H is the person's height in centimeters. So if I'm trying to get H by itself, so to get H by itself, we got to work outside in. So why don't you try pausing the video and see if you can get H by itself by working outside in. All right, first thing I gotta do, take that fraction, get rid of the fraction. The square root is not attached to the 60, so I want to move the 60 first. So I've got 60 BSA. Now to get rid of that square root, I gotta square both sides. Notice I just squared the entire other side. So 60 BSA in parentheses squared. And we are trying to get H by itself. So now I just got to divide by that W. So H is equal to 60 times BSA, all squared, divided by W. I determine the height of the person who weighs 90 kilograms. Okay, so that's going to be the W. And then this is obviously our BSA. So I'm going to go back here so I can do it on my actual equation. So my BSA was 2.1. And then it was 90 kilograms. So we're going to type this in our calculator. Okay, I'm going to type the top in first, press enter, then divide by the bottom so I don't do too much at once. So I'm going to do that 60 times 2.1. Then I'm going to square it. Then I'm going to press enter, then divide by my 90 so that it doesn't try to divide by 90 just at the end. So 176.4 is going to be the answer to this. Oops, 176.4, and then we got to check, what am I trying to label this here? We're doing height, so centimeters. Okay. Relationship between the length of a pendulum, L, in feet, and the time it takes for a pendulum to swing back and forth, one time, or its period T, is modeled by this equation. Solve for L. So Big Ben is the nickname of the bell in a well-known clock tower in England that stands 316 feet tall. The clock is driven by a 660-pound pendulum in the tower that continually swings back and forth. So that is his equation. So see if you can pause the video and solve for R. All right, so solving for L. If you haven't paused the video, make sure you pause the video and go ahead and solve it. Otherwise, I'm going to go ahead and start it up. So remember, we always work towards that square root. So outside in means I want to get rid of the 2 pi. So you could do them separately. I'm going to do them together. They're being multiplied, so I'm going to divide by 2 pi to get rid of it. So I'm going to have T over 2 pi is equal to the square root of L divided by 32. So that 32 is under the square root. So I'm going to square to get rid of this. Notice that I squared the entire thing. Okay, these cancel. So then I can multiply my 32 over. So 32 times t all over 2 pi squared is equal to L. So working outside into it, just making sure you're not moving things at the incorrect time. Okay, so then if the pendulum's period is 4 seconds, okay, determine the pendulum's length. So that means that t, I'm going to solve for L, okay, so it's easier to already just plug it into it. So my 4 seconds here, I'm going to plug in, so this is answering the next question. So 32 times 4 divided by 2 pi all squared. Okay, so we're going to type this in our calculator. So 32 times 4 divided by 2 pi, so 4 divided by, I'm going to put 2 pi in parentheses to say they're together in the bottom. So there's my 2 pi, and then we're going to square them. So notice how many parentheses I have. So 12.969. So 12.969 length. So we are talking feet. Right, our last one here, it says, consider the diagram shown. The variable r represents the Earth's radius, p represents the plane's height above the Earth in altitude or altitude in miles, and h represents the distance from the pilot to the horizon. So derive an equation to show the relationship between the three sides, then solve for h. Okay, so that is a right triangle. So I'm going to do Pythagorean theorem. So I'm going to label on here. I'm going to say this is my A, this is my B. Your C has to be across from your right angle. So what represents my Pythagorean theorem? A squared plus B squared equals C squared. Okay, so then my A in this is going to represent R squared plus my B, which is H. And then my C, to get the whole length, I have to do R plus P. So I'm going to do R plus P squared. Okay, so I have to solve for H. So I'm going to subtract this guy over. So H squared is equal to R plus P squared minus R squared. H is still not by itself, so I'm going to square root it. We're not going to do a plus or minus because we shouldn't have a negative length when we're talking about this. So square root of R, like so. Okay, if you wanted to simplify, we can take that R plus P squared and write it out twice and distribute. So R times R is R squared. R times P is RP. P times R is RP. P times P is P squared. That gets me 2RP. Okay, so if I go ahead and replace it, it's actually going to simplify it here. So I'm replacing that with what it is, double rainbow. So R squared plus 2RP plus P squared minus R squared. Because now, if I combine those R squareds, they actually go away. So 2RP plus P squared. Okay, so then the next question, use your equation. The Earth's radius is 3,959. The horizon is 225. We are trying to calculate the altitude. Okay, so if I'm trying to calculate the altitude, we're going to substitute the 225 in for the h. So 225 is equal to the square root of, I'm going to plug in the radius, which is 3,959 times the p plus p squared. So the easiest thing to do is we're actually going to, this you would have to use the quadratic formula to solve it. So what we're going to do is we're going to kind of cheat the system here. We're going to graph this. So I'm going to simplify this really quickly here. So 2 times 3,959. So it's a little bit easier to type in my calculator. So 2 times 3,959. 7918p plus p squared. So I'm going to type this in my y1 and this in my y2, and I'm going to graph both of them. Okay, and then we're going to find their intersection to see what p is going to equal. Okay, so here's my y1, here's my y2. I'm going to adjust my window here. So I'm going to make my x max 100. That one equation is already 225, so I just made them 800. As long as it's above 225, we should start to see it. So if I make that and I go ahead and graph it, there it is. So I'm going to press second, trace, intersect. And I'm gonna scroll as close as I can where they intersect. And I'm gonna press enter 3 times because it's gonna say first curve, second curve, guess where you think it is. So first curve, second curve, guess where you think it is. So 6.83 is going to be our answer. Okay, so 6.83 or 6.39, sorry, 6.39, and that will be your altitude. So your answer for that is going to be 6.39 for your altitude.